Okay, let's take a look at question 31 in topic set 7. This is a question that requires you to use the Bohr model, again, to calculate energy transition. And the Bohr model, remember, works for all one-electron system, both ions and atoms included. And the general equation that we have to remember from the Bohr model is that delta E is equal to negative RH times Z squared, which is the atomic number of the species, 1 over n final squared minus 1 over n initial squared for the transition of the electron from one orbit to another orbit. Okay? This question tells us that the spectral lines, one of those lines that we observe as the electron transition from one level to another, has a wavelength of 253.4 nanometer, and the starting orbit is n equals 5. The question is, what's the principal quantum number of the lower energy state? In other words, it's asking for the value of the final orbit. So the species that we're given is beryllium 3+, which is a one-electron species. So that means that we can use this equation to calculate the answer. If you remember, the change in the energy of the electron is then used to produce a photon, and the energy of that photon, of course, can be calculated using hc over lambda. And so that's what we'll start with. We're going to calculate using Planck's constant and the speed of light, and then the wavelength that we're given, the value of the energy of the photon. And so that value happens to be 7.845 times 10 to the minus 19 joules. Okay. Once we have that, we can say that the delta E is the negative of that number, and it's negative because it's emitting energy as the electron falls, and that's why the negative sign has to be present to indicate emission. And this is equal to negative RH, RH is this value, times Z squared. So Z for beryllium is 4, right? The atomic number is 4, so it's 4 squared, and then times 1 over n final squared, and we don't really know what that is. That's what we're trying to find out. 1 over n initial, the initial value of the orbit is 5, so it's 1 over 5 squared. Now what I can do is move these two numbers right here, to the left, and so it would look like this: negative 7.845 times 10 to the minus 19 joules over negative 2.178 times 10 to the minus 18 joules times 4 squared, and that should equal to 1 over n final squared minus 1 over 25. Okay? My joules cancel out. I can calculate out what this number is right here, and that ends up being 0.02251. Now, if I take my 1 over 25 and bring it to the other side, it becomes plus 1 over 25, and that's equal to 1 over n final squared. That ends up being 0.0625. So therefore, n final squared is 16, the reciprocal of this number, and then n final is the square root of 16, which is 4. So what has happened is the electron has gone from orbit 5 to orbit 4 in this case.